So there's my a, b, and c values. Plug it in like this. This ends up being 4 plus 4, which I could write as 8. Or I could look for that perfect square factor and write it as 4 times 2. So this simplifies to 2 plus or minus 2 root 2 all over 2. And these cancel out a little bit. And 2 over 2 is just 1 plus or minus 1 root 2. So based on this up here, n is equal to 1 and k is equal to 2. So they want to know what is the value of n plus k. 1 plus 2 is 3. In this equation we see two y equal statements. We can set them equal to each other and solve for 0. This allows us to set up our a, b, and c values for using the quadratic formula. Our a value is what's in front of x squared. Our b value is what's in front of x, and there is no x term, so it's 0. And this b minus 3 is actually our c term. If we plug these all in underneath the discriminant, we can find out the number of solutions. So if I plug in a, b, and c, and I simplify a little bit, if there are 2 solutions, then this whole value, whatever's underneath the radical, is going to be greater than 0. Now I can plug in my different values for a and b. 32 minus 24, it's 8, which is greater than 0. B works. So you can't factor this, so we got to use the quadratic formula. Plug it in like this. And 36 minus 28 can be simplified. That just becomes 8, which I'm going to split into 4 times 2, because 4 is a perfect square factor. So this becomes 6 plus or minus 2 root 2 over 2. And if I divide both parts by 2, I have 3 plus or minus root 2. Now they want to know the sum of the solutions. So 3 plus root 2 and 3 minus root 2. If I add these together, the root 2's go away, and my answer is 6. These are my a, b, and c values, the coefficients and the constants. If I plug everything in like this, I can simplify, and this becomes 44, which if I change to 4 times 11, I have a perfect square factor. So now I'm looking at 10 plus or minus 2 root 11 over 2, or 5 plus or minus root 11. They want to know what is the value of n. N is equal to 11. Those are my a, b, and c values, and if I have no real solutions, then that means this part, b squared minus 4ac, is going to be negative. So b squared minus 4 times 3 times 5 is b squared minus 60, has to be less than 0. If I add 60 to both sides, I get that b squared is less than 60. A. If a line intersects a parabola at exactly one point, the only possible line is either the bottom or the top. Otherwise, they would intersect at 2 points. So I will set the two equal to each other. Negative x squared plus 5x is equal to c. And I'll subtract c from both sides to get 0. And we have these 3 values. We're going to use the discriminant to find one solution. So b squared minus 4 times a times c, and this is true when it is equal to 0. So 25 minus 4c is equal to 0. Or in other words, minus 4c is equal to negative 25, or c is equal to 25 over 4. You could write that as 6.25 if you wanted to. These are both y equal statements. Set them equal to each other. Then we're going to subtract or add 3 to both sides. Now that it's equal to 0, I can look at my discriminant and use that to find one solution. So the square root of 10 squared minus 4 times a times c. And this part here will equal 0 when this is true, when there's one solution. So this is 100 minus 4a minus 12 is equal to 0. So minus 4a is equal to negative 88. So a is equal to 22.